Good morning, class.
Good morning, Lucky.
Okay. Last week we have learned
Good morning,
characteristics
Roshi.
and design of belt drives, and today we are going to study chain drives. Chain drives is another major type of flexible drive used to transmit power over long distance. Compared to belt drives, chain drives are usually used at low to moderate speed, and this chapter consists of 7 parts. You need to master the characteristics and applications of chain drives and the structural characteristics of chain drives and structure and material of roller chain pulley and the motion of chain drive, both analysis, calculation, and arrangement for chain drives. Chain drives combine some features of belt drives and gear drives. A chain drive consists of a driven sprocket and a driven sprocket and a chain loop. When transmitting power, the chain engages with two wheels which produce the same direction turning between parallel shafts. This table lists the difference between belt drive and chain drive. A belt drive consists of a driving pulley, and a belt. A chain drive consists of a driven sprocket, and a chain loop. There are two typical layouts of belt drive: the open belt drive and the closed belt drive. For open belt drive, the driven pulley rotates in the same direction as the driving pulley. For closed belt drive, the driven pulley rotates in the opposite direction to the driving pulley. But for chain drive, the driven sprocket rotates in the same direction as the driven sprocket. Compare with belt drives. Chain drives have high transmission efficiency, great power transmitting capacity, and long life. For belt drives, the different tensions on the tight and slack side lead to slight relative sliding between the belt and the pulleys, which is called elastic creep or slippage, but low slippage or creep is involved between the chain and sprocket teeth. belt drive is driven by friction on the contact surface between belt and pulleys, so its transmitting capacity is limited. While chain drive is machine drive, which is driven by the thrust between teeth, and the speed of belt drive is within the range from 5 to 25, and the speed of chain drive is less than 15 because of elastic grip. The speed ratio of belt drive is neither constant nor exactly equal to the ratio of two pulley diameters. Therefore, belt drives cannot be used where a constant output speed is required. For chain drives, the average speed ratio is constant and is determined by N1 over N2 or the ratio of J2 to J1. The average speed ratio is constant for chain drive. J is the number of teeth of the sprocket. In a power transmission system, belt drive is used at high speed stage, while chain drive is used at lower speed stage. For example, this is a typical power transmission system. The belt drive is mounted at high speed stage, and the chain drive is mounted at low speed stage. Both belt drive and chain drive can be used to transfer power over long distance, but chain drives can operate in hostile environments such as high temperature, dusty or dirty situations. The main disadvantage of chain drive is the impact and noise due to variable angular velocity ratio and velocity. So this is the advantage of chain drive. The chain drive has low elastic grip, and the required tension is small. The structure is compact, can work in high temperature and dirty environment, and the pressure is low. And this is the disadvantage of chain drive. There is impact and noise. So, chain drive are commonly used in conveyor systems, automobiles, motorcycles, and so on. This is the examples. There are examples of applications of chain drives for automobile engine, reducer, and chain conveyor. The chains include 3 types according to their applications. That is power, transmission chain, drag chain, and lifting chain. Power transmitting chain are mainly used to transmit mechanical energy. Its velocity is less than 20 meters per second, like this. And drag chain and lifting chain are used in covering machine and materials handling machine. For drag chain, its velocity is within the range from 2 to 10 meters per second. And the velocity of lift chain is less than 0.25 meter per second. Like this. This is a lifting chain. And power transmission chain can be further divided into roller chain and tooth chain. Roller chain can be manufactured in single, triple, a double, triple, and quadruple strands. The left finger shows the structure of a single strand roller chain, and the right is a double strand roller chain. The power transmission capacity of roller chain is usually below 100 kilowatts, and the chain speed is less than 15 meters per second. Its transmission efficiency is about 96%. This is for the roller chain. The right finger shows the structure of a single strand roller chain. It's composed of the pin, the bushing or sleeve, the roller, and the inner link plate and outer link plate. For example, this is the outer link plate, and this is inner link plate. This is the pin, the bushing, and the roller. And this is the second structure of roller chain. And for the materials, the chain materials, you can choose carbon, iron, or structural alloy steel. And the heat treatment can be used to raise strength and wearing capacity. This is the roller, the bushing, and the pin, the bushing, the roller, the inner link plate, and the outer link plate. In a roller chain, the pin, and the outer link plate, is press-fitted. So there is interference fit between pin and the outer link plate. The bushing and inner link plate are press-fitted too, so there is interference fit between bushing and inner link plate. The roller and bushing are slip-fitted, so there is clearing fit between roller and bushing. The pin and bushing are slip-fitted too, so there is clearance fit between pin and bushing. For example, this is the pin, the bushing, the roller, the inner link plate, the outer link plate. There is interference fit between pin and outer link plate. They are press-fitted, and there is interference fit between bushing and the inner link plate. So they are press-fitted too. So there is no relative movement between them. And there is a clearance fit between roller and bushing and pin and bushing. They are slip-fitted. So pins inside bushings and rollers inside each bushing to provide rolling engagement. The main parameters in a roller chain are pitch, P, roller diameter D1, pin diameter D2, length between inner link plates B1, link plate thickness T, the number of links LP, and strand spacing PT. The pitch P is the center distance between two adjacent roller centers. The larger the P, the larger the size of every element in chain, and the larger the transmitted power. When a higher power is to be transmitted, a multiple strand ruler chain is required. Like this. This is a double strand roller chain. The P is the pitch and is the distance between sprocket teeth, and it identifies the dimensions of a roller chain. D1 is the roller diameter. It determines the shape of sprocket tooth. And B1 is the wings between either link plates. It's an interior dimension corresponding to the wings of sprocket tooth. T is the link plate thickness. PT is strand spacing, and LP is the number of links. For multiple strand chains, the stress between each strand is not uniform. Some of the strand carries too much stress, so the number of strands is usually less than 4 to avoid uneven loading. And this is the main parameters of chain. The pitch, it identifying the dimension of a roller chain, and the roller diameter D1, and pin diameter D2, and wings between either link plates B1, the link plate thickness T, the number of links LP, and the strand spacing PT. And the number of chain pitches had better be even number, so that when forming ring, outer link plate connects inner link plate. Like this. But when the number of chain pitch It's odd number. It's odd number. We should use transition link like this, which commonly should be avoided because the transition link will corresponding force. Roller chains are standardized products. In China, the designation is indicated by chain number of strands, number of links, and standard number. Chain number is usually followed by a serial number A or B, and chain number indicates the pitch of chain in 16ths of an inch. Serial A is used in America and many other countries, where serial B is mainly used in European countries. Both serials are available in China. For example, okay, this indicates a serial A, single strand chain with a pitch of 12.7 millimeter and 87 links under standard GB. And this table lists standards and main parameters of A series roller chain, and this is the chain number. This is series A, and this is series B. This is chain number, and this is the corresponding pitch. The pitch P is equal to chain number times 25.4 and then divided by 16. For example, if the number is 8, the pitch is 8 times 12.4 and divided by 16. So the pitch is 12.7 millimeter. And if the number is 20 and the pitch is 31.75. And this is the wings PT, and this is the roller diameter D1, inner wings B1, pin diameter D2, plate height. So the and the chain is the parameters of chain is standard, and this is the limit load for single strand chain. If but for transmission chain, the limit load is 80% of the value. And this is the value of Q. the mass per minute of single strand chain. So if we allow the chain number, we can know these parameters of the single strand roller chain. And tooth chain is formed by connecting many tools template with hinge like this. And compared with roller chain, tooth chain runs sturdily. Its load is low. It have high ability to bear shock loading, but it has complicated structure, high price, and heavy weight. And the tooth chain is commonly used in high speed, can attain 40 meters per second, or in high motion precision. This is for tooth chain. Our class is based on roller chain. And when a roller chain structurally mesh with sprocket teeth, the sprocket can be regarded as a polygon. The cycle formed by the vertices of the polygon is pitch cycle. So this is the pitch cycle of driven sprocket, and this is the pitch cycle of driven sprocket. The number of sides of the pigeon is the number of sprocket teeth. This is J1. J1 is the number of sprocket teeth of driving sprocket, and J2 is the number of sprocket teeth of driven sprocket. And the length of the side of polygon is pitch P. And this cycle is pitch cycle. And for the roller chain pony, the basic parameters include the tooth surface arc radius RE, and the tooth groove arc radius RI, and tooth groove angle phi. This is the tooth groove angle phi. And pitch is the quarter length, like this. Calculation formula of main sizes of main pulley include the diameter of pitch cycle, and the pitch cycle, for the pitch cycle, the cycle formed by the vertices of a polygon. This is the pitch cycle D. So the diameter of pitch cycle D can be calculated by this formula. The D is equal to the pitch P divided by sine 180 degree over Z. Z is the number of sprocket teeth, and this is angle, this angle of this, and 180 degree over Z is half of this angle itself. So we can use this formula to calculate the pitch cycle D. If we know the pitch P and the number Z, we can calculate the diameter of pitch cycle. And then the diameter of atom cycle itself, dA. This is dA. We can use this to calculate dA, and the diameter of root cycle there, dF. dF is the diameter of root cycle is equals to the diameter of pitch cycle of minus D1. D1 is the roller diameter. So we can calculate the main sizes of chain pulley. Use these formulas.
Oh, Lucy, can you go back, Lucy, again? I have a question.
Okay.
Lucy,
Okay.
can you go back, Lucy, the previous slide?
Go back. There.
Here, this tooth groove angle. How you draw this angle, Lucy?
Which angle?
Tooth groove angle. Pi.
Tooth groove angle phi.
Yeah.
Yeah. Okay. Okay. There is the roller. This is the roller. Okay. Okay. And this is the tooth groove of the chain pulley. And this arc from there to there, they contact the ruler, contact the pulley within this ridge, this arc. They contact, this is the contact arc. And from the center of the roller, there and there, so we can obtain the tooth groove angle phi. It's corresponding. This angle is corresponding to the length of the contact arc.
Oh, where this small circle touched, we need to draw the line here, right?
Uh,
I said this small circle diameter is d1, right? So this circle, when we will draw this circle, and this circle will touch the line. So we need to draw the line to get this tooth groove angle pi,
yeah,
right?
yeah. Draw the line, and then you find the tooth groove angle.
Hmm. And what about this RE, tooth surface area, arc
RE,
radius? Yeah,
RE, RE is the tooth surface arc radius.
radius.
Yes,
Hmm.
you can draw, and you
The
can
arc,
draw for the arc. For the arc, you can draw a draw uh chord
yeah. But what about this center? Yeah, this
center.
center.
Yeah, you can draw chord to find the center. For example, okay, no. Draw a chord like this. Okay, there is a chord. Okay,
Hmm.
and then draw another chord like this. Okay.
Yeah, but what about the center? How I got this center to draw the arc?
Mm-hmm. Wait a minute.
Here,
Okay. There is
here.
two chord, and then we can draw a line perpendicular 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 to this chord.
Arc.
Okay,
Okay.
and then draw a line perpendicular to this chord, and this line and this line will
Will touch the center of the
yes,
arc.
yes, intersect, and this point, this point is the center. This point is the center, and this distance is the RE.
RE.
Okay, you can use this
Okay.
to find the center. Okay, and
Yeah,
then
Lucy.
to measure the distance. This distance is RE.
Mm-hmm. Okay, Lucy.
Okay, okay.
Yeah.
Any questions?
No question, Lucy. Okay.
Okay. So let's have a break. Okay,
Okay.
have a break for 20 minutes. Okay.
Okay, Lucy.
Okay.
Okay, Lodge.
嗯哼，
看照片，要看照片。妹妹，你想看照片？
哪个照片？我让我给你拿一下。
妈妈，妈妈来，妈妈，
哎，
妈妈来了，打开，这个，
那你这个拿出来看了。
哦，
我体检一下。
太注意，但是太也不起来，我还说了一遍呢。真是了不起。是了不起，你真是了不起。
Okay, let's continue.
Yes, 老师。
Okay. Have long the base parameters of the roller chain pulley and for the tooth surface arc radius RE and tooth groove arc radius RI and the tooth groove angle phi, and they are made arrivable from arrivable within a range, and this is for the minimal value and the maximum value. Use this formula to calculate. And then below the basic parameters, the pitch cycle diameter D is the diameter of the pitch cycle, and the atom cycle diameter dA, root cycle diameter dF, and the hole diameter for the sprocket dk, and the flange diameter dg. So this table lists the computer formula to calculate dA, HA, DF, and DG. And this table lists the maximum value for the hole diameter decay. If we load the pitch of the chain, the pitch, if we load the chain number, we can obtain the pitch. And then if we load the Z, the number of sprocket teeth, then we can obtain the value of the maximum diameter for the hole at the hole diameter, the maximum hole diameter for the sprocket. For example, if the chain number is is 0.8, so the pitch is 12.7. If the number of the sprocket is 15, then the maximum diameter for the hole is 28. This is the allowable maximum diameter of the hole. And in a chain drive, this is we can obtain the contact angle, which reflects the number of sprocket teeth in machine or carrying the load. The calculation of contact angle on a sprocket is similar to that of a belt drive. It can be expressed as this: the contact angle for driving sprocket alpha 1 and the contact angle is alpha 1 and the contact angle alpha 2. Use this to calculate. And we have the main parameter of chain pony, and then we should load the tooth shape of the chain pony. And for the transverse tooth profile, it includes 3 arcs and 1 straight line. In there, the arc AA, AB, and CD, the 3 arcs, and line BC. So the profile includes 3 arcs and 1 straight line. And this is the actual surface profile. It's arc plus straight line, the arc and the straight line. This is for single strand chain pulley, and this is for multiple strand chain pulley. And all the parameters you can use this table to obtain the parameters. Use this list there. You can find the value. And this is for series A and this for series B. This is for single strand and this is for multiple strand. And then similar to belt drive, the structure of chain pony is determined by the diameter. If the sprocket diameter is small, we can use solid type sprocket like this. When the diameter of sprocket is small, and if the diameter is middle, we can use power plate type sprocket like this. If the diameter is very large, we can use composition type sprocket like this. And this table is list the materials of chain pulley, and the material of chain pulley should ensure that the tools have enough wear resistance and strength. Okay, because the working condition of smaller chain pulley or the driving pulley is worse than that of larger chain pulley. So the smaller chain pulley is manufactured with better material. And this is a hardness, and this is a material. And then let's proceed to the next part. The speed analysis of chain drive. Okay. Since the sprocket can be regarded as a polygon with the length of the side as P and the number of sides as the number of teeth Z, the circumference of the sprocket is Z times P. If the rotational speed of the small and large sprocket are N1 and N2 respectively, the calculation of average speed of chain drive is similar to that of a belt drive. This is the average linear speed of chain. This is for V1. It's for driving sprocket. It's determined by the number Z1 times P times the speed N1 and divided by this. So for the average linear speed, the average linear speed of driving sprocket should be equal to that of driven sprocket. So it's equal to Z2 times P times N2 and divided by this. So this is the average N2 and it's equal to Z2 divided by Z1. So the average number Z2 and Z1 is each cycle we have this for the instantaneous linear speed is R1 of the driving sprocket. So this is the instantaneous linear speed we use to calculate. And then we this way is instantaneous linear speed of change direction along AB like this, and this cosine beta. And for this component, Vy is the speed times sine beta. The two components of the instantaneous linear speed. So the beta will change. The beta will change from this to this. Okay, from this to this. And this is beta can change from this to this. And then if beta is 0, if the beta is 0, so the Vx reaches the maximum value is R1 times omega 1, and Vy is 0 when beta is 0. And if beta is 180 degree divided by Z1, then it can obtain the minimum value of Vx and the maximum value of Vy. And then the Vx and Vy can variable from this to this and this to this. So this is the this is for the variation of Vx. So it's not constant for the Vx. Okay, and so we have this. The instantaneous ratio of I of a chain Is is equal to omega 1 divided by omega 2 is not constant, but the average speed ratio I is equal to Ni over N2 is constant. So for the chain drive, it's not suitable to be used in situations with high requirements of motion accuracy. And the driving pulley runs at constant speed. The driven pulley will run at periodically changed speed as the angle gamma and the beta changes. Only if J1 is equal to J2, we have I as is 1. So when chain drive works, vibration and dynamic load will be produced. This characteristic is called Poynting effect or Poynting action or quarter action of chain drive. And we can calculate the long uniform coefficient of speed or the quarter speed variation dirt. It's the maximum Vx minus minimum Vx and divided by Vm. Vm is the mean velocity or average velocity. And this is the vertical axis is the quarter speed variation, and the horizontal axis is the number of tools Z. We can say that the fewer the number of chain teeth, and the higher the dirt or the quarter speed variation will increase when the Z is decreased. And the more obvious the fluctuation of chain speed. So if we increase the pitch P or decrease the chain teeth Z, the delta will increase. The delta will increase. So the polygen action or polygen effect is a kinematic consequence of the polygen due to the pitch length in time, and the polygen action affects operating smoothness of a roller chain drive, particularly in high-speed application, and both quarter speed variation and polygen action decrease as the number of sprocket teeth is increased. So, if the number of the sprocket teeth is sufficiently large, that is, more than 21, the polygen action may be hardly noticed. Therefore, a large number of sprocket teeth or a chain with a smaller pitch give a uniform chain speed and smooth operate. And in chain drive, polygen effects lead to periodically change the movement of chain and pulley, which give rise to dynamic loads. At the acceleration at which chain runs lead to dynamic loads. Load F D1 is M times AC, and then we can know the impact force FD2. And if we increase the N and increase the pitch P or decrease the sprocket TC, then the FD1 will increase. And at the moment chain pitch is engaged with the pulley, the hinge of chain pitch moving in straight line and the teeth of chain pulley moving in a cycle at an angle speed omega will engage with each other abruptly at a certain relative speed, which makes chain and pulley to collide with each other and produce additional dynamic load. So large N, large Z, and small z, large P and small z may obtain relatively large impact load. So in order to, the polygen effect will cause transmission instability and dynamic load. So in order to decrease polygen effect, we should decrease the N and decrease pitch P and increase the sprocket number Z. And And usually J is more than 21. More than 21. And then is an initial tension. Initial tension or pretension F0 is applied when installing chain drive. In a chain drive, the upper side is in tension, called the tight side, and the lower side is called the slack side. Power is transmitted by the tight tension side, and the purpose of tensioning is to make the slack side not too loose to avoid vibration jumping off. But for belt, the purpose of tensioning is to obtain enough friction to transfer motion and load. This is the difference between chain drive and the belt drive. And the initial tension F0 is more for chain drive. And to ensure that the sag of slack side is not too large. F is the sag of the slack side. When mounting chain drive, chain should be tensed properly, and the force acting on the chain include the effective pull force or effective tension force from the transmitted power, and the centrifugal force and sagging force due to the weight of the chain, and the effective tension force Fe is expressed as this 1000 times P and divided by V, and this is determined by the transmitted power P and the speed of chain V. And for the centrifugal force Fc, the tension induced by centrifugal force Fc is analogous to that of belts as Q times V square. Q is mass of chain per unit length. We can obtain the value of Q from handbook. And the sagging force FF relates to the weight of chain, the center distance, and the layout of chain drive. For example, this is the suspension coefficient KF, and A is center distance, Q is the mass per unit length, and from there, the vertical axis is the coefficient KF, and the horizontal axis is F divided by A. A is center distance, F is the sag. And we have this. I have this. If if the ratio of F to A is increase, the KF will decrease. Okay. The F1 is the tight side tension force, and F2 is the slack side tension force, and F1 is Fe plus Fc plus Ff, and F2 is Fc plus Ff. So the tension force between tight side and the slack side is different. And this is at the final breaking of chain plate, vertical breaking, and the fingers breaking or impact vertical breaking of roller and bushing, and well, rollers and bushings and pins are split and sleep fitted, so there will be there will occur well, and the ring of pin and sleeve at heavy loads and high speed. The intensity of impact and contact stress increases, resulting local welding at the contact surface. So as the chain drive rotates continuous, the welded surfaces are forced to separate, resulting excessive wear or gunning, and overload tension break. This is the main failure modes for roller chain drive. And then we draw a limited a curve. This curve 1 indicate vertical breaking of chain plate, and curve 2 indicates the impact vertical breaking of roller and bushing, and curve 3 indicates the wear, and curve 4 is the limit power, which gluing of head restricts, and this is the actual used error for chain drive, and this is the power P, and this is M1, and this within the range is actual used error. And there, for this is under the condition when the chain drive is at bad seal and lubrication. And this is the selection diagram for chain drive, and the vertical axis is the power P, and the horizontal axis is the speed of driving sprocket M1. For example, if we load the M1 is 3 is less than 300 and less than 400, and also we lose the power is less than 20 kilowatts, and then we can find or obtain obtain the point. And the point is located in this error. This error indicates the chain number, means the chain number is 20 and with a series A. And then we can obtain the pitch is 31.75. So if we load the power and the speed n1, we can obtain the point, and then we can select the chain number. We use this selection diameter, and this special condition of above power curve. So if we use this selection diameter, it should satisfy that the two pulleys share the same plane, and the smaller pulley number J1 is 19, and the pitch's number of chain is LP, and the load is 30, and recommended lubrication mode can obtained from this table. From the chain pitch and chain speed, we can have different lubrication mode. If the point is located in this error, we use manual lubrication, and in this error, we can use drop fed oil, or in this error, we can use oil base, or in this error, we use oil injection. For this is for the lubrication mode, and it's a working knife to certify that. And then when lubrication is bad or the recommended lubrication mode cannot be used, we should decrease the P0. We should decrease the P0. And this is the design step and the methods of roller chain drive. When we design a chain drive, we can know this: the operation directions, the dimensions of transmission position, and the transmitted power, the speed of driven sprocket, and the speed of driven sprocket, or the speed ratio, and this is the conditions below. And this is we should design for the chain type, the number of links LP, the number of strands, number of sprocket teeth, and structure of sprocket size, center distance, and we also calculate the force acting on the shaft and determine the lubrication mode. So this is the content for design. And first, we we can determine the number of teeth of pulley. We know that if Z is too small, the pulling effect is large, and then the motion is unsteady. And uniformly for Z1, the driving, the number of driving teeth should larger than 17. If Z is too large, the structure size and weight will increase. And this is the number of teeth of smaller pulley or driving pulley Z1. And this is the chain speed. If the chain speed is within this range, we can choose the Z1 larger than 17. If the chain straight is within this range, we can choose the number larger than 21. This is for the selection of Z1, and the speed ratio is low. So then we can calculate the number of teeth of driven pony Z2. Use the average speed ratio I times Z1 times Z1. And then and then when where happens, the pitch will increase. The delta P is the pitch increment, and delta D prime is the variation of a pitch diameter, and then there is a relationship between delta P and delta D prime. And when delta P is not changed, if we increase the Z, the delta D prime will increase too. And then it will be called jumping over teeth or take off the chain. So commonly we take Z2 should less than 120. And the number of chain pitches is even in order to make very uniform. And the number of pulley teeth had better be odd. It is the optimum series for the number of pulley teeth. And this is for the transmission ratio. When the ratio is too large, the contact angle of smaller pulley will be too small. Okay, this will reduce mating teeth and wear of teeth is enlarged. And then we can determine the calculating power PCA. PCA, we know that it can use this to calculate Ka times P. Ka is coefficient of working condition, and P is nominal transmitted power. And from this table, we can find the value of Ka. And the allowable power is determined by P0 times Kj times KL times Kp, and KL is chain length coefficient. Kj is coefficient of number of teeth. Kp is coefficient of strength. This table is corrected coefficient Kj and KL for Kj and KL, and this is called coefficient of number of teeth Kj. If the number of teeth is 15, the Kj is 0.775. We can we can obtain the Kj from this table, or we can calculate use this formula, okay? And this is the coefficient of multiple strands Kp, and this is the number of strands. Usually, the number of strands is less than 4, and then for the pitch of 10, the bigger the pitch, the higher the bearing capacity, but the larger the shocking, or the larger of the Horniging effect. And the principle of determining pitch is, first, in order to make structure tight and to make life long, single strand chain of smaller pitch should be used. And when high speed and heavy load, multiple strand chain of smaller pitch should be used. And when center distance is small and the ratio is large, multiple strand chain of smaller pitch should be used. And when center distance is large and the ratio is small, single strand chain of large pitch should be used. And this is the principle for determining the pitch. And for center distance, we have this to calculate the center distance. If A is too small, at the same speed, the number of circulation increases, which can easily lead to vertical and wear. And if A is too large, chain is easy to shake. So the center distance is within this range. P is the pitch. And the number of chain pitches, LP, we can use this formula to calculate, but the result of calculation should be integer, and the number must be even, and for then the center distance A, can use this to calculate too, and the center distance should be designed to be adjustable. And then we obtain the maximum diameter of hole of small chain pulley. And from this table, according to the pitch and the number of teeth, we can determine the maximum diameter of hole of chain pulleys, dk max. If dk max smaller than the diameter of chain pulley shaft, the parameter of chain drive should be chosen again. And then when the speed of chain drive is very low, the chain may be destroyed because static strength is not enough. So we should calculate the static strength of tension and calculation of safety coefficients or safety factors. Use this, and the safety factor should within this range, within 4 to 8. N is the strand number of chain. F limit is the limit tension load of single strand chain. And KL is working tension force of tight side of chain. And KA is the working condition efficiency obtain drive can obtain from tables. And this is the chain number, and this is the corresponding F limit. You can obtain F limit from this table. And this is the parameter selection or parameter calculations when we design a chain drive. Okay, let's have a break. Okay, let's have a break for 20 minutes. Okay.
OK，老师。
OK，老师。
Okay, let's continue.
OK，老师。
When we do chain drive design, we should determine the number of sprocket teeth and the pitch, the number of strands, the center distance, and we should choose the structure of sprocket and so on. This is the design procedure. First, select the number of sprocket TC and the speed ratio I. Usually, speed the ratio I is low, and then the presample include the driven sprocket should have more than 17 teeth. Because if the number of teeth is small, the polygon effect will very large, and the speed ratio usually within the range of 2 to 3.5, and then we should determine the required power rating of a single strand chain P0. P0, we can use this formula to calculate. And P is the transmitted power. And Ka we can obtain from the working condition table. And Kj is coefficient of number of teeth. We also can obtain Kj from table, and Kp is coefficient of strength. And then we determine the required power P0. If we lose the P0, according to P0 and the speed of driven sprocket, we can select types of chain and pitch from the selection diagram. And then determine the center distance between sprocket shaft and the chain length LP, and LP is obtained from this formula, and LP should be integer, and the theoretical center distance can obtain from this, and then the actual center distance should be modified. And then select an appropriate lubrication mode according to the speed. From there, to select the lubrication mode from the speed and the pitch. Or you can use this table from your textbook. And then to calculate the force acting on the shaft. And to calculate the contact angle on the small sprocket, and then draw the sprocket parts drawing. And this is an example of a sprocket parts parts join like this or like this. And let's say example 7.1, and we should design a chain drive for a conveyor, and we know that the Ka is 1, and the driving sprocket speed is 214 revolutions per minute, and the driving sprocket speed is 80. Then we can calculate the speed ratio from the driving sprocket speed and the driven sprocket speed. And the nominal power to be transmitted P is 7.5 kilowatts, and center distance A is 600 millimeter. And then we lose these conditions, and we need to design a chain drive. So according to design procedures, first, we should specify the number of teeth of sprockets. First, we can obtain the error speed ratio I is N1 divided by N2. We know N1 is the speed of driving sprocket is 214, and we lose N2, and then the average speed ratio I is 3. It's 3. Okay, and suppose the velocity is 328 meters per second. From this table, we can select the number of teeth they want, and then we select the number of teeth of smaller sprocket Z1 is 25. You also can choose another value, maybe 27. Okay, and maybe 23, and then we calculate the number of teeth of the driven sprocket. We use Z1 times the speed ratio, the average speed ratio, and then we select Z2 is 75. It's 75. And then computer the design power PCA. We use this formula to calculate, and we know that P is 7.5, and the Ka is 1. Then we should determine the value of Kj and Kp. Kp from this table, Kj, and this is the number of teeth. For there, we choose the number of teeth. D1 is 25. Okay, it's 25. So we can choose Kj. This value 1.34. 1.34. Okay. And Kj, we choose Kj 1.34, and for KP, from this table, we know that KP is the coefficient of strength, and if for the single strand roller chain, KP is 1, and then we know that KP is 1, and then we calculate P0. P0 is KA. K is 1 times KJ. KJ is 1.34 times the transmitted power 7.5 and divided by KP. KP is 1, and then P0 is 10.05 kilovolts. So we know P0, and then we should select type of chain and determine the pitch P. And from the selection diagram, we know that the P0 is 10.05, and the speed of smaller pony N1 is 214, and then we found the coordination of the point, and the point is located there. And you can choose 16A series or 28 series for the chain. And if we choose 16A series, and then we can obtain the pitch is 25.4. Okay, and then we select chain 60A series with pitch P 25.4 millimeter to start design. Okay, and then we lose the chain number is 60A, and then we can obtain the main parameters of the A series roller chain, the pitch, the wings PT, the roller diameter D1, the inner wings B1, the pin diameter D2, the plate height H2, and below the Q, the mass per unit length is 2.6. Okay, from this table, we can obtain the main parameters for 16A series roller chain. And then we check the velocity, the V, linear speed V is Z1 times N1 times P1 divided by 16 times 1000. We know that Z1, we select Z1 is 25, and N1 is 240 revolutions per minute, and P1 for 60A series chain, the pitch P is 25.4. So the calculated velocity V is 2.4, and is less than 15 meter per second. So the velocity is acceptable. And so the choice of J and P is acceptable. And then determine the initial center distance A0 and chain length LP. The LPO can use this to calculate. We know that the center distance is 600. And Z1 is 25, Z2 is 75. And P, and we lose P, okay? And then the P is 25.4, and calculate LP0 is 99.93, and LP should be integer. So we choose LP is 100. Then we calculate the actual A is A0 plus J. So the actual center distance should be 600.89 millimeter. And then determine the lubrication method. Okay, so that we calculate V is 2.54, and we select the pitch P is 25.4, and from this table we lose the pitch and the change speed V. We calculate V is 2.54, and then the point is located in this error. So the lubrication method, we can choose oil base as the lubrication method, and then calculate forces acting on the shaft and determine the contact angle on the small sprocket. And we also can use a formula to calculate. Okay, so this is for example 1. Any questions? Any questions for this example? Any questions? Okay, no. You have no question. Then let me say the example 2. Example 2 should design a chain drive for a heavily loaded conveyor to be driven by a gasoline engine with a mechanical drive. The input speed is 900. Input speed is the speed of driving sprocket. Okay, and the desired output speed is from 213 to 214, and the output speed is the speed of driven sprocket. And the nominal power to be transmitted is estimated as 10 kilowatt. P is 10. Select chain 68 series as with a pitch of P is 25.4 millimeter, and then to design the chain drive according to the design procedures. So you have 10 minutes to design by yourself first. Okay? 10 minutes to design by yourself. Okay? According to the design procedure. Okay? 10 minutes.
Oh, okay, Laushi, we can try.
Okay.
Mama. Mama.
老师
Okay,
Laoshi,
let's continue.
yeah, Laoshi, can you solve this? I think
Okay, let's say the solutions. And from the design procedure, first select number of teeth. Do you finish this step?
a
Do you
number of
finish
teeth.
the number of teeth? Have you finished this step?
Yes, 老师。
Formulate.
So, okay. Use the average. The average output speed is this is N1 and this is average speed for N2. So I 3.83 and select this D1 as 21. You also can choose 23 or 25. You also can select another value, okay? And then calculate J2 is I times J1 and we select integral. And then the J2 is 81. Okay, this is for the selection of teeth of number of teeth of sprocket. And the value is not it's not standard or absolutely. You also can choose a large value. Okay, you can choose 23, 25. Okay, and then computer PCA, we load the transmitted power is 10. So select factor KA. KA is 1.5 and then can calculate KJ. You also can choose the KJ from a larger table. Okay. The value is not absolutely this is for KP and KJ. You also choose KJ. You select the number of teeth is 21. KJ is 1.11. Okay, and maybe there may be a little difference between the selected one and the calculated one. Okay, and for single strand chain, KP is 1. Okay, and then we calculate P0. If you use the value selected from the table, KJ is 1.11. Okay, it's 1.11, and P0 should modify to a ladder. Okay, and then from and then select chain, and in this example it has select the chain number. It's 16, a series. Okay, and we have load the pitch. Okay, we have load the pitch, and then to determine the center distance. Okay, below that center distance A0 is within a range. Okay, within a range, and there within a range is, let me say, the center distance within this range. Okay, is larger than 30 times p and less than 50 times p. Okay, and in this example we select A0 is 40 times p. Okay, it's 40 times p. And then we calculate LP0 and we lose P and we can calculate A0 and we lose Z1 and Z2 and then calculate LP0 is 133.3 and then the LP should be integral and then we select LP is 134. Okay, and select LP and then to modify the actual center distance A, use this to calculate to calculate the theoretical center distance A, and then to modify the A to the actual center distance A prime. Okay, and then we obtain the actual center distance, and then calculate chain speed. Use this, we select Z1 is 21 and we lose N1 and we lose P and calculate the linear speed is 8. Linear 8 is 8. And then from the table we lose the speed and chain and determine the lubrication mode. Okay, and then we select the lubrication mode, and then to calculate the force acting on the shaft, and we calculate FC, FE, the efficient force. Use this, okay, and then we calculate the force acting on the shaft. Use this to calculate FE, and then the contact angle can calculate. Use this formula, and we should it should satisfy that the contact angle should larger than 120 degree. So it satisfies that, and so the design is acceptable. So if you choose a different Z, if you choose a different Z1, the calculation or design procedure will different. And so you need to check the V. The V should check the V should less than 50 meter per second, and then this check the V should less than 50, and then check the contact angle should larger than 120 If you satisfy this, your design is acceptable. Okay, your design is acceptable, and this
Okay.
is for yes.
Actually, I'm lost. I don't understand. So, confusing.
What? What?
So confusing.
Which one?
This example, right? I really
Example?
don't understand. Yeah.
Example 2?
Yeah.
Which step? For which step you have
Well, actually, fine, no problem. I will go through it when I'm on the class.
oh, you have no problem.
I have problem, but I'll go through it when the class is over. I'll ask you the question next class.
Sorry, I can't understand.
I mean, it's okay, no problem.
No problem.
Yeah.
Oh, okay, no problem. And this is for the example 2. And then let's say the average of chain drive. First, we should know the principle of arrangement. First, the chain drive is often arranged in vertical plane. We should do our best to avoid arranging in horizontal plane or inclined plane. And second, the center line should be arranged horizontally or almost horizontally. The tight side of chain drive can be upper side or lower side, but it is better for tight side to be upside. And third, two shafts of chain drive should be parallel, and the two pulleys should be kept to share the same plane as far as possible. Otherwise, the chain is easy to take off. And this table, lists the origin of chain drive. And this is correct arrangement, and this is wrong. This is wrong arrangement. We consider the conditions. If the speed ratio I is larger than 2, and the center distance is within this range, the two shafts are in the if the two shafts are in the same horizontal plane, whether tight is upper side or a lower side, chain drive can work normally. So both of the two layouts acceptable. If the speed ratio is larger than 2, and A center distance is less than 30 times pitch P, two shafts are not in the same horizontal plane. Slack side. No. What's wrong? Slack side should be lower side. Otherwise, this is the wrong arrangement. Otherwise, the chain and the pulley can easily jam. And if I is less than 1.5 and the center distance A is very large, and when the two shaft is in the same horizontal plane, slack side should be lower side. Otherwise, when quantity of drop of slack side is increased, slack side will contact with head side. And if the speed ratio and center distance is any value, two shafts are in the same vertical plane. Let your quantity will decreases if a effective number of engaged teeth and the lower transmitting capacity. So we should use this to to adjust. First, we use adjust center distance, or use tension unit, or we use two staggered pulley like this. And this is the correct arrangement under these conditions. And this is the lubrication mode. Lubrication mode. The four lubrication modes. We can choose this lubrication mode according to the pitch and chain speed okay. And this is all for the this chapter, the chain drive. Okay, let's review this class. And first you should master the difference between belt drive and chain drive. And this is the typical power transmission system. Usually, we use belt drive at high speed stage and chain drive at low speed stage. And this is a gear reducer, and next class, we start to study gear drives. This chapter is gear drives is very important because when you do your course design, you should design a gear reducer. You should design a gear reducer as your course design content. Okay. So from next class, we study the gear drives. And then you should know the types of chain, and you should focus on the power transmission chain. And usually the roller chain is used. It's used, and you should master the composition of roller chain, and master the parameters of the roller chain, and these basic parameters for sprocket is important, but in this course, you should master the basic conception for this. You needn't to calculate the values, and then we should know some calculations. For example, the contact angle, and you need to know how to choose the structure of chain pulley or chain sprocket. It's according to their diameter. And then you should understand the polygonal effect and know how to decrease the polygonal effect. Usually, we can decrease the speed n and decrease pitch and increase the number of spliced teeth, okay, in order to decrease the polygonal effect. And then the force acting on the chain, and you should master the selection diameter and master the design procedures of the chain drive. And in our test for this chapter, you needn't to design, and you should master the basic conceptions of chain drive. And any questions?
No,老师。
Okay. Oh, okay. No questions. So, this is for today's class. Okay.
Okay, thank you, 老师。
Okay. Next
Okay, Master.
next class we will study the gear drives. This chapter is very important. Because you should know how to design the gear drives in your course design. Okay.
Okay, 老师。
Okay. So class is over.
Thank you.
Okay. See you
Thank you,
next
Lottie.
time. Okay.
Bye, bye, Lottie.
Bye bye.
Okay.